Hello, my pre-calculus student. In this video, we are going to evaluate composition of trigonometric function and the law of sine. So let's begin with the following example. We ask to find the value of sine of inverse tangent of 1/2. So the first thing we are going to do is that we start with the innermost function. So we start with the inverse tangent first. So first, we are going to find the inverse tangent of 1/2. To do this, we will have to sketch a right triangle. And we are going to label, so tangent is opposite over adjacent, so the opposite is 1, the adjacent is 2, and the inverse of tangent of 1/2 is give me the angle theta. So from the diagram, we can conclude that theta is the answer for inverse tangent of 1/2. Then we use the Pythagorean theorem to find the hypotenuse. So therefore, I'm going to label, so I'm going to call this to the C. So we do 2 square plus 1 square equals C square, and C is our hypotenuse. So that will give us 5 equals C square, or square root of 5 equals C. Now we can conclude that the values of sine of inverse tangent of 1/2 is sine theta is sine theta. Now sine theta is opposite divided by hypotenuse. So let's go ahead and substitute the opposite is 1, the hypotenuse is square root of 5. But we don't want to have square root in our denominator, so we are going to rationalize the denominator. So we will multiply by square root of 5 to both denominator and numerator. So therefore we can conclude that sine theta is square root of 5 over 5. Therefore, sine theta is the composition of sine and inverse tangent. Wait, this we have run out. Sorry. Inverse tangent of 1/2, that will equal square root of 5 over 5. Next, we are going to introduce the law of sine. So this will our objective 2. We apply the law of sine to solve triangle that not right triangle. And the law of sine can only apply for the following cases. We can only apply the law of sine if we know two angles and a non-inclusive size, what we call AAS, or two angles and included side, or ASA, or two sides and the included angle, SSA. These are the three cases that you can apply the law of sine for non-right triangle. So how we can write the law of sine? The law of sine say that sine of the angle 8 over the side opposite with the angle 8 equals sine of the angle B over the side opposite with the angle B equals sine of the angle C over the side opposite with the angle C. Now we use uppercase letter so we use uppercase letter to represent the angle and lowercase letter to represent the side opposite with the angle. So that's the law of sine. So just remember that we only can use the law of sine if we know two angles and one non-included side, or AAS, or two angles and one included side, or ASA, and the last can be two sides and the included angle, so SSA. So let's begin with the example. So in this example, I'm going to call this the example that we are going to apply the law of sine given two angles and one non-included side, so AAS. So let's get the picture or diagram. So we know the angle A, 35 degrees. We know the angle B, 103 degrees. And we know the little b, the side that opposite with the angle B, is 20. So that's all we know. Two angles and one non-included side. So now we need to find two missing sides. So to find the little a, and this angle C, and then find the little c. Okay. So the first thing we have to do is that we want to find angle C. So to find the angle C, since we know that the sum of three angles is 180 degrees, we know that the angle A and the angle B, so we take 180 minus the sum of the angle A and angle B, so therefore angle C be 180 minus angle A will be 35 and angle C will be 103 degrees. I'm sorry, angle B. So therefore the angle C will be 42 degrees. So now we found angle C. Next, we are going to apply the law of sine to find the sine 8. So we are going to use only two ratio sine of the angle A over little 8 equal. So we have to make sure that we know two sides. We know two angles and one non-included side. So therefore we know the angle A, and we also know the angle B. So sine of the angle B and the side B we also know. So let's go ahead and substitute the angle A for 35 degrees. So sine of 35 degrees. Little a we do not know. The angle B is 103 degrees. And the side B will be 20. So now we are going to do cross multiply, because this equation we want to do cross multiply so that we end up with an equivalent equation without the denominator. So it will be 20 times sine of 35 equal, and sometimes in the calculator or in the book they put parentheses around the input. You're welcome to do that. A times sine of 103. So now we need to solve for 8. We want to divide both sides by the number sine of 103. So 20 times sine of 35. So put them in the calculator. We end up with a estimate about 11.8. So now we know side A, we know side B, we know angle C. So now we just need to find side C. Now we cannot use the Pythagorean because this is not a right triangle. Again, we are going to use the law of sine. So I'm going to make a note right here, apply the law of sine to find letter C, or to find side C. So I'm going to do sine. We'll make sure we have to know two angles. So in this case we know the angle B and the angle C. Now what happens if you say I don't want to use the B and C, can I use the A and C? That's fine. It's okay. You still end up with the same answer with us. So letter B, letter C, so then we substitute. So the angle B be 103 degrees. The side B is 20. The angle C is 42 degrees. Side C we do not know. And of course the next step, to eliminate the denominator, we do cross multiply. So therefore you will end up with C times sine of 103 equal 20 times sine of 42. So now we need to find C, so we divide both sides by the number sine of 103. Put them in the calculator to end up with C around 13.7. So now we know all the sides and all the angle for our oblique triangle or our non-right triangle. So let's write that this summary. In this video we learned this, how to evaluate composition of trigonometric functions and the law of sine. Thank you so much for watching this video. Goodbye.